Okay. So let us now ask a very central question of what is probability. Okay, so we have defined probability with Kolmogorov axioms, but actually we can define probability, but actually there is no real meaning attached to probability. And since this is an issue that was raised by many students, then it's worth addressing this question. So this question has been discussed by many people, and in particular there is a number of scientists that have argued that probability is subjective, is a subjective notion. So each of us give an estimate of a probability of an event, such as the probability that it will rain this afternoon. And each of us may give a different probability. But what is important is that the way in which we compute probability must be consistent with rationality and common sense. Okay, and if you demand this to our way of computing subjective probabilities, then you end up with the same rules that we have, with the same axioms that we have defined for probability in Kolmogorov axiom. So one way to see this was pioneered by a mathematician called Bruno De Finetti. And Bruno De Finetti was a remarkable figure. He lived in Trieste for some time because he was working at General Insurance Company, and then he also held a chair as a full professor at the University of Trieste. And what he said is that the probability of an event A should be the degree of confidence that we have that this event will actually occur, okay? And or that this statement, you can think of probability also attached to statements, such as the one before. And in this case, it would be the probability that a particular statement A is true. And okay, so how do we quantify? How do we quantify how do we make this notion a little bit more quantitative? So the idea of Definetti was to use lotteries. Okay, so the idea is the following. So for each event, you can think of a lottery that gives you, say, say euro if A is true, or if it occurs, and 0 euro otherwise. Okay, so so you can think of, for example, A being anything, but say if you apply this to, for example, horse races, then you can think of A as being the event that horse A will win the race. Okay. And okay, so the main question is how should we price a ticket of this lottery? So what is the price of a ticket of this lottery? So if we think of P of A as being the price of this lottery, then this price should satisfy some condition. First of all, well, the price should be non-negative, of course, because you can win a positive amount of money. And also, well, it is clear that this price should also be less or equal to 1, because essentially you cannot charge more than €1 for a lottery that gives at most a payoff of €1. Okay, so we are thinking here of how should we give a price to this lottery, which is a fair price. So a fair price is a price under which an individual would be equally likely to buy or to sell, or would be indifferent between buying and selling tickets of this lottery. Okay. So okay. So in particular, so if A is true, then the fair price should be equal to 1, and if A is false, then if this event A will never occur, then this lottery is worthless, so the price should be 0. Okay. Now, if so, of course, this price measure the likelihood or the the plausibility of A to be true. Okay, and we think that it should be an increasing function of the plausibility, so that a more plausible statement should have a lottery whose ticket costs more than the lottery, the corresponding lotteries of less likely outcomes. And this is, for example, what you see in horse races. So the favorite horses, the odds are smaller for the favorite horses. Okay. So this P of A should be an increasing function of the plausibility and should go from 0 to 1. And now if you have two statements or events, A and A prime, then you can define two lotteries. And now if these two lotteries are equally, if these two events are equally likely or are considered to be equally likely, then the price of A should be equal to the price of a ticket of lottery A prime, if A prime are equally likely. Okay, then you can also consider if you have these two lottery A and A prime, you can consider also a lottery for the event that either A or A prime occurs. Okay, and you can consider also the associated lottery. So, and if A and A prime are exclusive events, either A or A prime or none of the two occurs, then it must be true. Then the price of the lottery for A or A prime should be equal to the price of lottery. Sorry, the price of lottery for A or A prime should be equal to the price of the lottery for A plus the price of the lottery for A prime. And why is this so? Because if it were not so, if I buy a ticket of the lottery of A and a ticket of the lottery of A primes, and then this is what I will spend, and this should be equal to what I would spend if I buy a ticket of this lottery here. Okay, so you see that the price of lotteries essentially satisfies the same conditions for that we have specified, the same condition that we have specified in Kolmogorov axioms of positivity, normalization, and additivity on exclusive events. And so this indeed you can show that this way of defining probability as a quantification of the degree of confidence about statements actually satisfies the same rules of probability. And also it gives you a practical way if you want to compute what is the probability that a certain individual attaches to a certain event. Okay. Now indeed, what Definetti did was not only to provide a foundation for probability as a subjective for subjective probability, but he also his ideas are also very much at the basis of financial mathematics, because you can think of that buying an asset in a financial market, buying a stock or buying even an insurance is equivalent to buying a lottery. Okay, a lottery that will give you a certain outcome if certain conditions are satisfied or other outcomes. Okay, so and indeed this theory of probability that he developed is essentially now the basis for how you compute the prices of financial assets, which is called asset pricing theory. And he also laid the foundation of portfolio theory. Okay, so how should you manage risk, a portfolio of risky assets?